Essentially, these first parts of the question that we're looking at is just kind of a plug and play, right? We recognize that radians allow us to develop this formula. Rather than just having theta being some degrees that has no meaning, in this case, I'm saying theta is actually L divided by R. How many times does the radius fit inside the arc length? Which allows me to develop this formula. L is equal to R theta. So if I have R, which is the radius, if I have theta, which is what?
The angle.
The angle at the center of the circle when we have that arc length.
Does it have to be in the center?
Yeah, good question, Callum. Does it have to be at the center? Well, when you look at this wording, when you look at this wording here, this idea of something being subtended, it's essentially saying the angle which is created at the center of the circle. That's what subtended means. Okay, they use that funny word there, but that's what it means there. It has to be the angle that's created at the center of the circle, given that arc length. Okay, when you I guess change your arc length. Yeah.
So it's subtended changing.
It's sort of more like a compass almost, right? Like imagine like opening and closing a compass. Let's have a look at these, okay? Just the first couple of ones, right? So example A. I've got an angle of pi and 4 subtended at the center of a circle, radius 5. So really, right, I'm trying to find the exact length of an arc, right? When you see exact length, what are you thinking there? But here, I don't even have to use that, right? Because before, this was my problem. Theta, being some degrees, was just kind of arbitrary. They just kind of picked 360 degrees as a whole circle. But now you've got this new idea of what theta is. It's not just an arbitrary number now. There's actually a definition to it, right? It's how many times does your radius fit inside that arc length. Because of that, I can actually just rearrange it to find the arc length now, using that new definition. Does that make sense?
Yeah.
Yeah, good. All right, awesome. For B now, right, pretty easy. What's the difference? They haven't given me an angle, have they?
It's just one.
So what would that be in terms of, what do I need to use here?
Well, it's 90, so it would be half, it would be pi over 2.
Pi over 2. Can you see how important it is that we actually use radians here? If I just said, oh yeah, theta is equal to 90 degrees, I can't actually use that in this formula, right? Because this formula assumes that I'm using radians, right? It doesn't work if I'm not using radians, because theta doesn't have that definition in radians. You have to be
Do you have
using...
to change centimeters into meters?
This one here?
Yeah.
No, we'll just leave our units in centimeters, yeah. Anyway, let's just keep going. So the arc length is equal to what? Well, I've got my R, that's, what's that?
But how do you know, how do you know 90 equals pi on 2? Oh no, I got
Convert it to radians. But I would just stick with the units I give.
You get a different answer because then it'd just be pi.
It'd be in different units.
Yeah. Right.
So just stick with the units I give you, right? So you got 200 times, what's my angle again, theta? Pi on 2?
Uh-huh.
And then you're right, that's just going to simplify really nicely. What would that be?
100 pi.
100 pi, right? And in this case, I wouldn't mind 100 pi's actually. But in this case here,
Because
right?
you're chubby.
What units are you using? What units are you using? Centimeters. And what do you actually find? You're finding the arc length. So that's the distance.